Alright, so we've got this, a ball is thrown up in the air. Ball is thrown up in the air from 5 metres above the ground. After 2 seconds, the ball reaches a maximum height of 9 metres. It lands on the ground 5 seconds after it was thrown. Find the quadratic function that models the situation. Write it in standard and vertex form. This is a very good question to go through for your assessment, by the way. Okay, so let's model this with a graph first. So looking at that situation of a ball being thrown, what are the axes? So the y-axis and the x-axis, but what are they actually? Yeah.
So the x-axis would be time.
So this would be time.
And the y-axis would be height.
And this would be height, the height of the ball. And basically then we have to sketch it. So it says, ball is thrown up into the air from 5 metres above the ground. So what we really need is a point here, don't we, at 5. Okay. And then it says it reaches a maximum height of 9. So let's put a 9 in there. So you don't have to do this, but I'm just going to put a little dotted line to help me sketch. So that's its maximum height. And then it says it takes, lands on the ground 5 seconds after it was thrown. So if I put another line here, and that is going to be 5, so for seconds, right? So what's it going to look like? It's going to kind of go up, reach a maximum at 9, and then come down.
Yeah.
Okay. So it says, find a quadratic function that models this situation. Right. What are your ideas? Yeah. Well, that's going to be a base of it, isn't it? Y equals negative x squared. It's not going to be just negative x squared, though, is it? Yeah.
Negative x squared plus 5.
Okay, so we also know it's going to have a plus 5. We do know that we've got a...
Yeah.
The vertex here is at...
Or no, it's at something that...
Yeah, so we've got x, so we've got x at 9. And we've got an intercept at 5, 0, not 0, 5. Right. So we've got a coordinate here at 5, 0, and we've got another coordinate at 0, 5. We know we've got a negative x squared. We know we've got a plus 5 on the ends. Anything else? Yes.
Oh, anything else?
Go on. Well, whatever you want to say.
So I was going to think maybe to find the other x-intercept, we need to find, I don't know if you would do this first, because I'm thinking, like, can you solve the x-intercept without having the vertex? But anyways, you would create a situation, because you know there's 2 possible answers. You would have to have x minus 5 being 1, and then x plus something else being another.
Okay, so you're saying we could look at it as y equals, say, x minus 5 and x plus something else, which is basically going to be what it goes down to here, yeah? Because that's going to be a negative something. Take it.
How did you get negative x squared? Like,
Kieran said it.
How do you know it's negative?
How do we know it's negative x squared?
Because it's concave down.
Okay. So I don't know it's negative 1x squared. He made that assumption, but I do know it's negative something x squared. So maybe I should write it's negative ax squared.
So normally it's like this.
Yeah, so a positive quadratic is like that. That's a positive a, and a negative a will be that way. Yeah.
Substitute 9 for y and the general formula with, because we know c.
Okay, so we could write, we've got y equals ax squared plus bx plus 5. Yeah? So it's like, say, negative a. And we know a coordinate is,
9, 4, 9, 1 y.
so we've got x9, so we've got 9 equals negative ax squared plus bx plus 5. Yeah?
And then we know that the x is equal to negative b over 2a.
Okay. So we've got x is negative b over 2a. And what's that as well?
That's the same for the y.
Find the x-intercept.
And do we know that?
No, we don't
No.
know one of them.
But we combine both of them. And simultaneous. We are missing
Okay,
one.
so we've got some simultaneous equations going on. So what would you do at that point? Is there anything else we can know?
Oh yes, it says yeah, we know the vertex point. It's 2, 9. It says after 2 seconds the ball reaches a maximum height of 9.
There you go. Right.
Okay.
Make sure we read it all properly. So actually this is at 2. Yeah?
Yeah.
So we've actually got 2, 9.
Okay. Now you can.
So we can change this to be 2. Alright? Go on then.
Okay.
Anything else that you can share? We're doing this together for those people that are... We've got lots of information here. It's just about putting things together.
Now because we have the vertex, we can put it in vertex form, which is y is
Vertex form, good. So we've got y equals...
negative bracket x squared minus 2 squared
x minus 2 squared
plus 9,
plus 9.
and we can expand the bracket to find the standard form.
Is
Where do you get the
that, is
negative
that,
minus 2 squared? Oh, because of the
because the vertex is at positive 2, positive 9, so we've got positive, right. Does that work?
yes.
Sure? So if we expand this, what do we get?
We get y equals
So we're going to negative, it's going to be x squared minus 4x plus 4 plus 9, which is then minus x squared plus 4x minus 4 plus 9. That gives me negative x squared plus 4x
plus 5.
plus 5, which is what we wanted.
Yeah.
If we didn't get that, we'd have to have something else.
Okay.
Make sense?
I think I just forgot. How do you put something straight into the vertex form once you have the vertex?
We use the vertex. So do you remember we start everything at 0, 0 with x squared. So if we look at the process that we would need to get through to this. So basically, you start and you think about your transformation of functions. We start with x squared. Alright,
Okay.
so f of x equals x squared.
Yeah.
Well, I want it the other way up to start with. So I'm going to first of all do that. So that would be what? That would be negative f of x. Right, I know it from transfer. So therefore I've got negative x squared. Now I need the vertex to move across to 2 and up to 9. So that would be negative f of x minus 2 and then plus 9. So that would be negative x minus 2 squared, that bit, plus 9. So that's how we do that in vertex form. That's why vertex form is so useful for us. So just to let you know, what would you have to do if when you wrote it like that and you didn't end up with the plus 5? What would need to be added to it? Your a value would need to change, and you'd have to put in, use your points to be able to figure out your a value. All right. Does that help you with that one? Does that help everyone?
Yeah.
That's a big one, guys. Hint, hint. Make sure you can understand and do that. Oh, you're right, nice. We are recording. So I'll just let you know. What's up? Okay, so then we wanted to have a look at question 5 on page 119. So the speeds of car passing a speed camera on a highway recorded. Are you with me on this one? Okay, page 119.
Which one?
Question 5. So we've got a table there, and it says the speeds of cars passing a speed camera on a highway are recorded. Can you interpret that table for me, please, just quickly? Greg?
So a majority of the cars are, are seen going between, like, a lot of the cars are seen going from 80 to, like, 110 kilometers per hour.
So what kind of table have we got there? Not cumulative frequency.
Grouped frequency.
It's grouped frequency. Okay? 80 to 90 is called a
Range.
That's it.
class interval. Okay? So that's a group, and then we've got the frequency, which they've written as number of cars. So it says calculate an estimate for the mean speed of the cars. What do we do? Right.
So for all the numbers of cars, you just assume it's halfway through the class interval.
Yes.
So for 60 to 70, the class interval is 60
Well,
to
what do we
70.
do for V is less than or equal to 60?
Oh, well, there is no cars in that situation, so we don't have to worry
We
about
don't have to worry about it. Okay. That's nice. So I'm not going to do it all because not necessary. So we've got this table. So we've got this one of the class intervals is 60 to 70, and we've got a frequency of 10. So we have to first of all find the midpoint of the group. Yeah. So the midpoint of this class is 65. So we do 65. Then we do. Well, we've got to add up all the numbers and divide by the total number of numbers, don't we? So how do we add up 10 lots of 65? We do 10 times 65, which is, so this is where we say it's the midpoint times the frequency. So we've got 650, and then we keep going down, and then we finally sum. Talking about your sigma, midpoint times frequency. You add all them up, and that equals something, whatever it is. Let's just say that, I don't know, I'm not going to guess actually. It's quite big. What do you then divide by? Nathan? The total frequency. So we've got to actually add up the frequency. So we've got to add up all these numbers. It's what is the worst thing that people do, the big mistake, sorry, not the worst, but the big mistake people do. Here.
So let's divide by.
Yeah, the mistake is dividing by the wrong number. They divide by 9 in this case, instead of dividing by 200 and, what is it?
200.
Is it 200?
It's 300.
200.
I haven't added them up, so
Easier
whatever
cumulative,
you-
so you can see table.
Oh yeah, if you look at below, your cumulative frequency is 300, isn't it? So the sum of these frequencies is 300. Okay, so whatever we get when we add them up, we divide it by the 300. That gives us the estimate. All right. It then says here is a cumulative frequency for the same data. Write down the values of A and B. Yeah, that's quite simple, right? Does anyone want us to go through it? It's only simple if you know it's simple. Everyone all right? I think this was your question. Was it your question? Was it? Okay. So you're happy with that now, yeah? You can do.
Yeah, sure. It was just.
So what is A?
A? Well, it's 93 plus 74. You can do that right now?
No, all right. As long as you know that's what it is. It's fine. But so you'll get A. You got A. I'm sure it's a good question. I'm pretty sure most other people would have made a mistake.
A question is I meant A for like B.
No. I was asking you to find A in part B just
Oh, okay.
just to check you know. But your main question was part A.
Yeah.
That was it then, yeah.
Yeah.
Okay. So I then Nick asked about box and whisker plots. So
Like interquartile range and stuff like that. Like and how to put it into a box and this.
so do you remember your 5-point summary,
Oh, was that?
Ethan?
You have the minimum number, and you have their quartile one,
So you have the lower quartile or quartile 1.
and then quartile 2, the middle quartile.
So the quartile 2 is also called the median. Quartile 3 is called the upper quartile, and the maximum value. Okay, so they're the points you know, and then what you do is you will have a number line on computer. Drawing it. So you'll have a number line, and then you just place your lines where each one is. So I will have a line at maximum, I will have a line at lower quartile, a line at median, a line at upper quartile, and a line at the maximum value, and I draw the box and the whiskers. Yeah.
And then if they ask like, oh, what's the interquartile range? That's just the box, right?
Yeah. So just the interquartile range, by the way, like you're saying. Let's say that value is at 15. This value is at 24. Let's say this value is at 17. That value will be at 3, and this value at 31. What is the interquartile range?
Did you say 9?
You would say 9. Yeah? You wouldn't say 15 to 24. The interquartile range is 9. How much of your data is in with each section?
25%.
25%. So 25% of your data, 25% of your data, 25% of your data. So how would you describe the distribution of data either side of the median? Nick?
Well, in the lower quartile, it's very dense, so there's a lot of data between 15 and 17. Then from the median to the upper quartile, it's more spread out.
Okay, so I like most of what you said. I didn't like one little bit, which wasn't technically wrong, but I just didn't like the fact you included it. When you said there's a lot of data. Yeah, there is 25% of my data in every single bit. I did like what you said when you said in the lower quartile, below the median, the data is more compact, there's less spread. I wouldn't say a lot of data because there is exactly the same amount of data in above the median, it is just more spread out.
What you said is like would you say there's a lot of density, or is you say it's more dense instead of saying there's a
Yeah, I
lot
just said
of
more
data?
You could say
or
dense if that's what you
All
want
the
to
data
say.
is more closely grouped together.
You could say closely grouped together, yeah. Whatever comes across as I think the best way of explaining. Just be very careful of saying anything to do with the amount of data, because the amount of data, well, it doesn't tell me how much data is there at all. So a box and whisker plot does not tell me anything about how much data there is until I get told the total amount of data, and then it's just an even four-way split between each group, and then we look at how spread out it is. All right. Why is the interquartile range important? Greg?
Because the interquartile range eliminates any anomalies in the data. Not really.
Sort of, but you've got to be careful. It's not necessarily just anomalies.
It's like where most of the data is like bunched together.
Most of the data, again, is a bit kind of like saying there's more data there. And it's not, is there? There's half of the data in the middle, and there's half the data not in the middle. So it's not most of the data. We've got to be a bit more.
It's a 50% that represents the data the best.
Yeah, so we would say the middle of the data range. The only thing you said was anomalies or outliers. We could say the extremes of our data. We kind of ignore the extremes because that's where kind of we tend to maybe have one or two bits of data that may be slightly more extreme than the rest. Because this whisker, for instance, I might have all my data here and then one here. Have I eliminated an outlier by not considering that whisker?
Yeah.
no.
Why not?
Actually, no, because there's a way to check.
Yes, it's not an outlier, is
Because
it?
it's not 1.5 times the interquartile
Exactly,
range.
good. To know if it's an outlier, I need to take that distance, add it on, and then do another half. Okay, so that's 1.5 lots of the interquartile range, and anything outside that is an outlier or an anomaly.
1.5 times 9.
So 1.59, so I've got 24 plus 1.5 lots of 9, and I've got 15 subtract 1.5 lots of 9. Go off the other end as well. Okay, so in this box and whisker plot that I've just drawn,
Nothing.
there are no outliers in it at all. There's just, we could maybe say the middle data is where it's most representative. We don't have the extremes, so careful. And that is, by the way, the kind of stuff that you would have to be able to discuss where standard won't.
Okay.
All right? They might be able to get away with saying it ignores outliers. You won't.
Okay.
Does that help you with your box and whisker? Is that
Yeah,
what you need?
that's jogged my memory.
Is there anything else anyone's identified at this stage?
It's not, well, it's above the exam, but are you going to mark ours and Mr. Cunningham going to mark theirs?
We first off, but then we'll come together and we'll moderate and check that I've given the right marks. It will be marked differently, so because I have to mark different